Yeah, I hope all the participants are installed the EMTP software, and today we will go with some hands-on session. So we will go with the load flow analysis, short circuit analysis and protection. After that, we will go for the wind energy integration and transient stability analysis and other things. We will go with the small examples and we will add one by one for one example itself. So can you please open the EMTP software? All of you, can you please open? You can type EMTP works. All of you, can you please open the EMTP works? Just you can type the EMTP works in the start menu. After opening the EMTP software, just you can create a new file. You can click on this new button, EMTP default design. You can select EMTP default design and click on create. After opening the EMTP software, just you can click on the new. In the file tab, you can click on the new on left side. Select EMTP default design and click on create. Select EMTP default design and click on create. Now one new file is opened here, right? Just you can save that file. One new file is open here. Just you can save that file by using Ctrl S or click on the save button in the file tab. I am saving this file as a load flow. You can save your name. After opening the new document, just you can save the file load flow and click on save. After saving the file, now we can connect the circuit like this. For that, we require the voltage source and switches, transmission line, and one of the transformer and load. We can connect like this. So for that, just you can go to the source library. After opening the EMTP software, you can create a one new file and save that file. After saving the file, just you can double click on the sources library and take AC voltage source and impedance. You can take AC voltage source and impedance into GUI. After opening a new document, you can save that file and go to the sources library and take AC voltage source and impedance into GUI. Just you can double click and drag to GUI. After that, you can go to the switches library. Take ideal switch or ideal switch breaker symbol. Anything you can take, both are same. Just you can take the switch from the switches library. Just you can take ideal switch breaker symbol or ideal switch into GUI. From the sources library, you can take voltage source and impedance. And from the switches library, you can take ideal switch or ideal switch with breaker symbol. Anything you can take, you can connect. After that, the other end of the switch is connected to bus, three-phase bus. So we need to draw the three-phase bus here. For that, in the home tab, you can find the draw signal. In the home tab, you can find the draw signal. Just you can click on that arrow mark next to the draw signal. In the home tab, you can find the draw signal. So next to the draw signal, you will find the arrow mark here. And you can take draw three-phase bus. In the home tab, you will find the draw signal. Just you can click on that arrow button. You will find the draw three-phase bus. You select the draw three-phase bus and you can draw. You can draw up to what point you require, and after that, just you can click and escape. For drawing the bus, in the home tab, you find the draw signal. There is an arrow mark is available. Just you can click on that arrow mark and take draw three-phase bus. After that, just you can connect like this. The other end of the switch is connected to that bus. After that bus, we have a transmission line in the circuit. So for the transmission lines in EMTP, we have a different line models are available. Here on the right side, you can able to see in the RLC branches, you have a pi models are available. If you have the RLC components or positive sequence and zero sequence components of RLC parameters, directly you can take that pi model. If we are going for the switching transients and lightning transients, you need to model the transmission line as a frequency dependent model. So for that, we require the transmission tower configuration. It is a two-step process, right? So for that, just you can go to the lines library. For transmission line modeling, here I model the frequency dependent transmission line. For detailed configuration, we will go with the transmission configuration, and from that we can generate the parameters of transmission line. And model. For that, just you can go to the lines library. Just you can double click on that lines library and take line data. Just you can drag and drop the line data into GUI. For transmission line modeling, just you can go to the lines library and take line data.
Excuse me, ma'am.
Yeah.
Sorry to interrupt.
Yes, sir.
What is after that voltage source? I just missed it.
Okay. It's a switch, sir. From the switches
No.
library.
Before that.
This one. So this
That is whole is the voltage source.
Yeah, yes, sir. This is the voltage source with series impedance. There is
Okay. Fine.
in
Thank
the
you, ma'am.
okay, sir. In the sources library, you can find that one.
Yeah, I just take it voltage source only.
Okay, sir.
Thank you.
Okay, sir. From the sources library, you can take voltage source with impedance. After that, from the switches library, you can take switch, ideal switch with breaker symbol, or ideal switch, you can take any one of the one. For connecting this bus, in the home tab, you can find the draw signal. You can click on that arrow mark. You can find draw three-phase bus. You can take that one and you can draw that three-phase bus. After that, for transmission line modeling, just you can double click on the lines library. You can take line data. Just you can double click on the transmission lines library on right side. You can take line data. Now you can double click on this line data. After taking the line data into GUI, just you can double click on that line data. From the lines library, you can drag and drop the line data into GUI and double click on that line data. So after double click on that line data, you can find the different tabs. After double click on the line data, you find the different tabs here. So in the conductor data, we need to enter the DC resistance value of the conductor and horizontal distance and vertical distance of the conductors from reference point and midspan of the conductor. We need to enter these values. So in EMTP, for each and every component, you can find the help tab. So just you can click on that help tab, open conductor data. You can click on that conductor data. So here you can able to see the complete each and every tab detailed documentation. So in conductor data, in the conductor data help documentation, you will find one example file for the transmission line modeling here. So we can take the reference point of the horizontal and vertical distances like this. In this example, they are taking the ground as a reference. and this red color line represents the vertical reference point. So here he is calculated the horizontal and vertical distances of the conductors from reference points. So one side we can take it as a positive, another side it is negative. After that, they provided the phase conductors and ground conductors resistance values, diameter and thickness by diameter value, all the things they provided. Otherwise, we can calculate the thickness by diameter value and we can enter that value as a skin effect correction factor. So you can find the detailed documentation here. Similarly, so like this we can enter the DC resistance, outside diameter, horizontal distance and vertical distances of the tower. All the things we can enter. So but for vertical height at the midspan, we need to enter this value as, if we know the sag value of the transmission line, then we can enter this value as vertical height of the tower minus sag value. If we don't know that value, then we can take the vertical height at the midspan as same as that of the vertical height of the tower. We can take both as equal. So in this documentation, they provided the average value at the midspan as, they are using some formula. If we know the sag value, we can directly enter the vertical height at the midspan as vertical height of the tower minus sag value. Otherwise, we can take both are same. Like this, we can enter the values. So here, I am taking the default database available in EMTP software. For that, just you can click on that use database. For that, just you can click on that use database. And take 400 kV single circuit. To enter those values, it takes more time. For that, just I am taking the database values already available in EMTP software. Just you can click on that use database in conductor data. Just you can click on that use database and take 400 kV AC ACSR single circuit and take 400 kV ACSR single circuit and click OK. And you can take 400 kV single circuit and you can click OK. Just you can click on that use database available in the conductor data. You can click on this use database and take 400 kV ACSR single circuit and click OK. So after that, here you can able to see the parameters of horizontal and vertical distances of the transmission tower configuration of 400 kV single circuit here. So here you can able to see the phase numbers represented as 1, 2, 3. The phase numbers of the conductors RYB or ABC are represented as 1, 2, 3 here. And the ground conductors are represented as 0. To represent the phase numbers, we can add the phase values, the number values 1, 2, 3 as phase numbers. To represent the ground conductors, we are adding as a 0 here. To represent the ground conductors, we represent the phase number as 0. And here you can able to see the skin effect correction factors and bundled conductors. In this example, they are not provided the skin effect correction factors here for the single circuit line. But for bundle conductors, they are at the number of conductors in the bundle as 2, and the spacing they provided as 45 centimeters, and angular position they mentioned as 0. If we have the bundle conductors data, then we can enter the bundle conductors data and its spacing in the conductor data tab. After that, just you can go to the modal tab. After taking the 400 kV single circuit data into conductor data, just you can go to the modal tab and select the model as a frequency dependent FD. Just you can go to the model tab and select the model as a FD model. After that, just you can go to the model tab and select the transmission line model as a FD model. Next, you can go to the line length tab and you can enter the transmission line length as 50 kilometers. Here I am taking the transmission line length as 50 kilometers. After entering the conductor data from default database available in EMTP, just you can go to the modal tab and take the transmission line model as a frequency dependent model and go to the line length tab and enter the transmission line length as 50 kilometers. After entering the transmission line, just you can go to the generate data tab. After entering the transmission line length as 50 kilometers, just you can go to the generate data tab and you can provide the name for your transmission line. Here I am adding 50 kilometers. You can provide the file name here and enable run this case. You can provide the file name here and enable run this case and click OK.
Ma'am, can we change? Sorry, ma'am. Can we change the frequency to 50 hertz, ma'am?
Yeah, yes, sir.
In the model data, can we change the frequency?
Yeah, yes, sir. Just you can. Okay. For that, just you can take this. You can disable and you can change to 50 hertz. I forgot that one. Just you can change the transmission line frequency to 50 hertz. For that, just you can go to the modal tab and disable this one. You can disable this one and enter the model frequency as 50 hertz. Next, you can go to the line length and enter the transmission line length as 50 kilometers. After entering the parameters of conductor data, model tab and line length, just you can go to the generate data tab and you can change the data file name to some name. It may be 50 kilometers or anything you can provide. And you can enable this run this case. After enabling this one, just you can click OK. After entering the parameters of conductor data, model tab and line length tab, just you can go to the generate data tab and you can enter the file name as 50 kilometers and enable run this case. and click OK.
Ma'am, actually, what is that line model specifications means different CP, exact PI, wideband, FT?
Okay. Okay, sir. Different transmission line models are available. CP means constant parameter model. In that constant parameter, normally in pi model, it is not take the propagation waves. Traveling waves, it is not considered. So for detailed modeling, we will go with the constant parameter model or frequency band model or wideband model. So for the constant parameter model, it will consider the propagation constant, but it is not suitable for the high frequencies. If we are going for the high frequencies, constant parameter is not suitable. So that's why we will go with the frequency dependent model or wideband model. Both are same. The frequency dependent model and wideband models are same. For detailed modeling of transmission lines in high frequencies, wideband is most preferable compared with the frequency dependent model.
Okay, okay.
Excuse me, ma'am. Sorry to disturb you. Still, I'm getting feature missing, ma'am, while I'm trying to download that license file.
Okay, ma'am. For that, just you can go to the C drive, ma'am.
Yeah, I tried that one also, ma'am. Yesterday, sir kept that message in the group, ma'am. I tried that one also. In that case, also, I'm getting the same thing, ma'am.
Okay, you already pasted that license file into the program data of your C drive, right? You try that one also?
Yeah, ma'am. Yeah, ma'am. I tried that one also, ma'am. Yesterday, you said you will give some trial version for which is valid for 15 days. Can you share that one, ma'am, if possible?
Okay, ma'am. After the completion of training program, I will provide, ma'am.
Okay, ma'am. Thank you, ma'am.
Okay,
Thank
okay,
you.
ma'am. Yeah, sure, ma'am.
Okay, ma'am.
Hello, madam.
Yeah, hello, ma'am.
Ma'am, yesterday you have provided demo version, madam, but the device size is limited to 60.
Yeah,
So,
yes, ma'am.
if you give 15 days trial version, that will be helpful for us, ma'am.
Okay, okay, ma'am. Normally, we are not provided the trial version for the students. For professors and other people, we can provide the trial versions, ma'am. Just you can go to the EMTP website and you can register for the trial version. Then we can provide, ma'am.
Okay.
Ma'am, is that valid for 15 days, ma'am?
Yeah, yes, ma'am. It is valid for 15 days with 5,000. The limitation of the devices is 5,000, ma'am.
Okay, ma'am.
Yeah.
Directly we can
Or
download it from EMTP website.
no, ma'am. Just you can go to the EMTP
Oh,
website and you can request it for the trial version. So we can provide the trial version
okay, ma'am.
license details with you. So accordingly, you can download.
Okay, ma'am. Okay, ma'am.
Okay, ma'am.
Thank you.
Yeah. After entering the parameters, just you can go to the generate tab and change the data file name, and you can enable run this case and click OK. So here you can able to see the error messages here. So in the downside, after generating the parameters, here you can able to see the error here. So we can check what is that error. So here you can find the error stop messages here. So sometimes if we are modeling the transmission line data as a frequency dependent model, just you can double click on the transmission line data. If we are, sometimes we will get this error message. So for that, if we are modeling the frequency dependent line model, we will go to the fitting tab and we can increase the number of poles. Here I am, by default it is 25. Because of the fitting, we will get error message here while modeling the frequency dependent line. So to solve that one, So we can increase the maximum number of poles to 35 or 40. Because of the fitting process, we will get some error for frequency dependent transmission lines. For that, just you can double click on the line data and go to the fitting tab. And you can increase the maximum number of poles to 35. And go to the generate tab, and again you can enable run this case. Then go to the generate data tab, and you can enable run this case and click OK. Now here you can able to see the transmission line calculation parameters are ended. The programming is ended. For modeling the frequency dependent transmission lines with long length, sometimes we will get the error message while generating the parameters. So to avoid that error message, just you can go to the fitting tab and you can increase the maximum number of poles to 35 or 40, up to you can increase 50 number of poles. So here I am increasing the maximum number of poles to 35. By default it is 25. Just you can increase 10 more poles, 25 to 35. And you can go to the generate data tab and enable run this keys and click OK. So after that you didn't find any error in the transmission line calculation. So to see the output responses, on the downside you can see the input file and output file. You can click on that output file. So from the web you can able to see the output parameters of RLC from the transmission tower configuration. So you can able to see the series impedance, shunt admittance, all the matrices you can able to see from the output file of transmission tower parameters. Like this you can find the output file here. Now we already generated the transmission line data parameters. Now we can import these transmission line data parameters into the transmission line. For that, just you can go to the lines library and you can able to see the different transmission lines here, CP model and frequency dependent line and wideband line. Here we are modeling the transmission line data as a frequency dependent. So you can take frequency dependent line here. Just you can drag and drop the frequency dependent line into GUI. After generating the parameters,
Ma'am, cable is for underground cable, right?
yeah, yes, sir.
Yeah, both are same.
Yeah, here you can find two types of frequency dependent line and cable. Cable is a separate, that is for cable data we can enter. Here we are entering the transmission line data, so we can take frequency dependent line. That cable is same for both underground and above ground cable, sir.
Okay.
So here just you can take the frequency dependent line and you can double click on that frequency dependent model and you can select the data file. You can drag and drop the frequency dependent line FD model into GUI. You can double click on that FD model and click on the select data file. While click on that select data file, the EMTP automatically opens your transmission line data here. After click on that select data file, just you can take here, I am saving my file name as 50 kilometers. Just you can click on that 50 kilometers and open. Now we are importing the parameters of transmission tower configuration into the frequency dependent line model. For that, just you can take the frequency dependent line into GUI and you can click on the select data file. and you can select your file name. Here for me it is 50 kilometers and click on open. Now the file is opened and click OK. Like this we can import the parameters of transmission tower configuration into the transmission line model. After selecting the file into the frequency dependent model, so here we are getting the three phases, 1, 2, 3 we are getting. So from this we can connect the individual phases into this three-phase bus. So in EMTP we have a conversion of three-phase to ABC and ABC to three-phase. For that just you can go to the pseudo devices library. For connection of individual phases into three-phase, in EMTP just you can go to the pseudo devices library. You can take bus to ABC. So from the pseudo devices library, you can take bus to ABC. So just you can drag and drop the bus to ABC and you can connect. To connect the individual phases into three-phase bus, you can go to the pseudo devices library and take bus to ABC and you can connect like this. Similar to the other end, we will connect bus to ABC. You can use before click on the EMTP GUI. You can use your arrow buttons on your keyboard for rotating the device. Before connecting any one of the component into the GUI, before click on the GUI, it is on the mouse. The component will be on the mouse, so you can use your arrow buttons to rotate the components. So just you can rotate and you can connect. Otherwise you can use flip horizontal or flip vertical also. Just you can right click and you can use flip horizontal or flip vertical. You can use any one of that. You can use flip horizontal or flip vertical for connection of other end of the transmission line. So after that I can connect one of the bus to other end of the transmission line again. For that just you can go to the draw signal in the home tab and you can click on that arrow mark and take draw three-phase bus. For connecting the other end of transmission line, I'll connect that other end of transmission line to three-phase bus. For that, just you can go to the draw signal in the home tab and click on the draw three-phase bus and you can drag and connect the other end of transmission line like this. You can connect the other end of the transmission line like this. So after connecting the bus, just you can connect one more switch. You can copy this switch or from the switches library you can take. Just you can connect one more switch here. Just you can connect one more switch here. So the other end of the switch is connected to the transformer. Here I am using step down transformer. So just for that you can go to the transformers library and take three-phase nameplate input. Just you can go to the transformers library and take three-phase nameplate input. Just you can drag and drop the three-phase transformer nameplate input and you can connect. After connecting the bus to other end of the transmission line FD model, you can take switch from the switches library and you can connect that switch to transformer. For that, just you can go to the transformers library and take three-phase nameplate input. And take three-phase nameplate input. And the secondary of the transformer, I can connect to the load. For that, just you can go to the loads library. Load models library is there. Just you can go to that load models library. And you can take PQ load with load flow. You can go to the load models library and take PQ load with load flow and you can connect. After connecting the bus to from switches library, you can take ideal switch with breaker symbol. And from the transformers library, you can drag the three-phase nameplate input. And the secondary of the transformer is connected to the load model. So here I am taking the PQ load with load flow. You will get that one from load models library. You can take the PQ load with load flow and you can connect the circuit like this. So after connecting this circuit, now we can enter the parameters for each and every component. After connecting the circuit, we can enter the transmit parameters into the each and every component. Further, just you can double click on the component. Just you can open the voltage source with impedance. Just you can double click on the component. So after double click on the component, you can change the voltage to 400 kilovolts and frequency to 50 hertz. You can change the voltage to 400 kilovolts. And change the frequency to 50 hertz. Just you can double click on the voltage source with impedance. And you can enter the voltage value as 400 kilovolts. And change the frequency to 50 hertz. After that, you can go to the impedance tab. So in the impedance tab, if you have the impedance data values for equivalent grid, directly you can enable the impedance data and you can enter the sequence data inputs for RL and R and L. If you have the equivalent impedance data, you can enter those values in the impedance data tab. If you
Madam, sorry to interrupt.
yes,
Hello?
sir. Yeah, hello, sir.
No, we don't have 400 kV generator. No, if I want to go for a real time practice, I have 24 kV generation only. So why do I use 400 kV generation and then I use for 11 kV or 24 kV generation and then use a step up transformer to transmit?
Yeah, yes, sir. That is also possible. We can do just for the normal purpose, for simple purpose only. I am created like this.
Okay, my
After
question is
stepping
that
up,
we have only 11 kV and 24 kV real time applications, right?
yeah, yes, sir.
If I publish a paper like this, it can be what is called they won't accept, right?
Yeah, yes, sir. After stepping up of the voltage, after reaching the 400 kV, just I am stepped down to 33 kV and I can connect the load. Just
Okay,
for simple
okay,
purpose only, just I am taking that one, sir. We can do like that also.
okay, madam. Okay, thank you.
Okay, sir. Just you can change the voltage to 400 kV and you can change the frequency to 50 Hz. After that, you can go to the impedance tab and you can change the nominal voltage to 400 kilovolts. If you have the three-phase and single-phase short circuit MVAs, you can enter those values. If you don't have that values, if you have the three-phase and single-phase short circuit MVAs, we can enter those values in the impedance data tab for calculation of R and L parameters. Otherwise, just we can enable the three-phase short circuit current. And here I am taking for 40 kiloamperes for 400 kilovolts. Here I am taking the 40 kiloamperes short circuit current and click on update impedance data. So it automatically calculates and provides the updated values of impedance parameters here in this tab and click OK. So in the impedance tab, if we have the impedance parameters, then we can directly go to the impedance data tab and we can provide. If we don't have these parameters, then we can enter the short circuit current 40 kiloamperes and X by R ratio. From that we can calculate the impedance parameters. So just you can click on that update impedance data. It will automatically calculate and it will provide the impedance parameters in this table. And click OK. After that, just you can double click on that switch. After that, just you can double click on that switch. And you can close this switch in steady state. Just you can click on the close it in steady state and never open. Just you can double click on that switch connected to that voltage source. And you can click on that close it in steady state and never open. You can click on that close it in steady state and never open. And click OK. Similarly for switch 2, just you can double click on the switch 2 and you can close the switch in steady state. You can click on that close it in steady state tab and click on never open. So for the switch 2, just you can click on the close it in steady state and never open and click OK. So we already imported the parameters of transmission line model here. We need not require re-import that one. We already imported the parameters of line data into this transmission line model. So just I'm closing the switch in steady state and click on never open for both the switches. After that, just you can double click on the transformer. After that, just you can double click on the transformer model and you can change the connection type as a star ground delta minus 30 degrees. Just you can change the connection type as star ground delta minus 30 degrees. And you can enter the nominal power as a 50 MVA. And you can enter the nominal power as 50 MVA and change the frequency to 50 Hz. And change the frequency to 50 Hz. And you can enter the HV winding voltage as 400 kilovolts. So my equivalent grid voltage is 400 kilovolts here. So for my winding 2 voltage is 33 kilovolts here I am added. Just I am step down the voltage from 400 kilovolts to 33 kilovolts. Just you can double click on the transformer model and change the connection type to star ground delta minus 30 degrees and nominal power to 50 MVA and change the nominal frequency to 50 Hz. And you can enter the voltage, winding 1 voltage as 400 kilovolts and winding 2 voltage as 33 kilovolts. So I didn't change the R and X parameters here. So if you have the magnetization characteristics, from that magnetization characteristics you can calculate the current and flux and you can enter the values here. Otherwise, you can exclude the magnetization branch model and click OK. After that, just you can double click on the load. So for this load here, you can able to see we need to enter the single phase data for P and Q here. So for this PQ load with load flow, we need to enter the single phase data. For that, just you can change the nominal voltage to 33 kilovolts. My secondary voltage of the transformer is 33 kilovolts. Just you can enter the 33 kilovolts here. And you can change the active power to 10 megawatt and reactive power to 4.5 MVAR. You can add the active power to 10 megawatt and reactive power to 4.5 MVAR and you can change the frequency to 50 Hz and click OK. You can double click on that load model load 1. Here we need to enter the single phase data. For active and reactive powers. So for that here I am entering my nominal voltage as 33 kilovolts. The secondary of transformer is 33 kilovolts here. And my active power is 10 megawatt. And reactive power I am taking as 4.5 MVAR. And you can change the frequency to 50 Hz from 60 Hz and click OK. So after entering all the parameters, if I need to perform the load flow analysis, we require the load flow bus. So in EMTP, we have a load flow bus is available. Just you can go to the sources library. Just you can go to the sources library. And you can take load flow bus. To perform the load flow analysis, here I am connecting the load flow bus here. So just you can go to the sources library and you can take load flow bus and you can connect. So while you can double click on that load flow bus, here you can able to see different load flow buses, slack bus, PQ bus and PV bus. From the sources library, you can take the load flow bus and you can drop to GUI. And you can connect the load flow bus to the equivalent grid. And double click on this load flow bus. So here I am taking this load flow bus as a slack bus. And change the frequency to 50 Hz. And you can enter the control voltage as 400 kilovolts. You can take the bus type as a slack bus and you can enter the frequency as 50 Hz. And you can change the control voltage to 400 kilovolts. So at the time of load flow analysis, all the load flow buses are open circuited and all the current sources are short circuited. So all the voltage sources are open circuited and all the current sources if we have in the circuit, that is short circuited. So we need to retrieve the impedance data from the equivalent grid into this load flow bus. For that you can select the retrieve impedance data from VWZ1. If you click on that arrow mark, you will find the VWZ1. After connecting this load flow bus only, you will get this VWZ1. This is the name of this equivalent voltage source here. So you can retrieve the impedance data from VWZ1 and click OK.
We are not able to get the retrieve operation. Hello?
Yeah, hello sir.
Hello?
Yeah,
Madam,
hello.
we are not able to apply the retrieve impedance data option, ma'am. Can you just check it, ma'am? How to just do it? Do that?
So after connection, you can connect this load flow bus to this equivalent grid. Before the switch, you can connect.
Yes, ma'am.
Yeah, after connection, just you can double click on that load flow bus and you can click on that arrow mark, retrieve impedance data.
That is not being enabled, ma'am. I don't know what has happened.
Okay, one thing you can do, sir. Just you can click on the control button and you can double click on any one of the component, whether it is highlighted or not, you can check. That load flow bus is highlighted. Just you can
Control and
control and you can double click on any one of the component.
okay.
Yeah, you can check.
Ma'am, the load flow is not connected. The load
Yeah.
flow is not connected, ma'am. It is not highlighted.
Yeah, okay. So for that, just
So,
you can remove that connection and you can connect again. I think it is not
okay,
properly connected. So just you can remove the connection and you can connect again. So while connecting,
okay.
you will get this node. So after connecting this load flow bus, just you can double click on that load flow bus and you can enter the bus type as a slack bus and control voltage as 400 kilovolts and frequency as 50 Hz. And you can retrieve the impedance data by using this arrow mark. If you are changing the name of the
Yes, ma'am. Got it.
Okay, sir.
Got it. Thank you. Thank you.
Okay, sir. Okay. You can select that VWZ1 and click OK. So after completion of this one, now we completed to enter the all parameters. So to perform the load flow analysis, just you can go to the simulate tab. Just you can go to the simulate tab, simulation options. Just you can go to the simulate tab, click on the simulation options. Just you can go to the simulate tab. You can click on that simulation options. Here you can able to see the find load flow solution. So just you can enable that find load flow solution and you can change the power frequency to 50 Hz. Just you can go to the simulate tab, simulation options and enable the find load flow solution and you can change the default power frequency to 50 Hz and click OK. Now you can run the simulation. After that, just you can run the simulation. So downside, you can able to see the number of iterations to complete the load flow solution here. So it will take 3 number of iterations for giving the best results. For me, it takes 3 iterations only. So if you want to see the output file, just you can click on that load flow web. After run the simulation is ended. On the downside, you can able to see the load flow web here. Just you can click on that load flow web to see the output results. So one web file is opened. So here you can able to see the voltages and power flows. All the things you can able to see in the load flow web. So to see the output results, just you can click on that load flow web and you can able to see each and every node voltage. Not this one, yeah. You can able to see the every node voltage and you can see the transmitted power from each and every node. Like this, you will get the output results. So if you want to see the bus voltages and transmitted powers on GUI, for that we require one tab in this GUI. For that, just you can go to the options library and take view steady state. For that, just you can go to the options library and take view steady state to represent the voltages at the buses and transmission, power flow through the switches and transmission lines. We require one more tab in the GUI. That is, you can find that one in options library. Just you can go to the options library and take view steady state tab. Just you can drag and drop that view steady state tab into GUI and double click on that view steady state and you can change the frequency to 50 Hz. Just you can double click on that view steady state tab in the GUI and you can change the frequency to 50 Hz, and you can take the power base as 1 MVA. For that you can represent this as 1 e power 6, 1 e6. To represent the power flow, just I am taking my power base as 1 e6 here, and I am changing my frequency to 50 Hz, and you can enable the load flow solution and click OK. So to see the output results in the GUI, we require one more tab, that is View Steady State tab. You can find this one in Options library. Just you can double click on the View Steady State tab, and you can enter the values as solution frequency as a 50 Hz, and you can enable the load flow solution, and you can take the power base as 1 e6 and click OK. So after that, just you can click on that bus. After that, just you can click on that bus 1 you can click and right click. You can select the bus 1 and right click. You can select the bus 1 and right click. You can click on that signal parameters. Just you can select the bus 1 and right click. Go to the signal parameters. And you can take the nominal voltage as 400 kilovolts. So to represent this bus voltage as in per unit, so I can take the nominal voltage as 400 kilovolts here. If you want to see the positive sequence voltage, then you can enable this positive sequence voltage and phase voltages. Just here I am adding both positive sequence voltage V1 and phase voltages VA, VB and VC for that bus, and click OK. Similarly for bus 2, just you can select that bus and right click, go to the signal parameters, and you can enter the nominal voltage as 400 kilovolts because there is no step down and step up transformer here in between the bus 1 and bus 2. So you can enter the nominal voltage as 400 kilovolts, and you can take the positive sequence voltage and phase voltages. Whatever the voltages you want to see in the GUI, just you can enable that positive sequence voltage and phase voltages and click OK. After entering the parameters in bus 1 and bus 2, just you can go to the design tab, and you can click on that show data or refresh. Here you can able to see the voltages of the buses directly in the GUI. After entering the signal parameters into the bus 1 and bus 2, just you can go to the design tab, and you can click on the show data or refresh. Just you can select the show data or refresh. So here you can able to see the positive sequence voltages and phase voltages directly. After that, you want to see the power flow through the system. So in EMTP, we can get the power flow results through the switches and transmission lines only. So for that, just you can select the switches. You can select both switches by using Shift tab in your keyboard. You can select both the switches. To see the power flow through this system, just you can select both the switches, and you can click on the device steady state options in the design tab. After selecting the switches, just you can select both the switches by using Shift in your keyboard. Just you can click on that Shift and you can select both the switches. Then you can go to the design tab and you can click on the device steady state options. Then you can go to the device steady state options in the design tab and you can enable PK and QK. Just you can click on the device steady state options and select PK and QK. If you want to see the current, then you can click on IK.
Ma'am, we had, excuse me, ma'am.
Yes, sir.
Hello.
Yeah,
Madam, we are doing something in three phase, no, ma'am? Are we not? Ma'am, we are doing in three phase, no, ma'am?
three phase?
So for three phase device only.
Yeah,
So
yes, sir.
there are
These
two
all-
options, no, ma'am. Three phase device and this is three phase, no, ma'am.
Okay, okay. Okay, one. Yeah, it is three phase devices, sir. Here you can select. 1 second, sir. Yeah, you can directly
So
enter
that's the
this.
second below option, ma'am.
Yeah, this is only for currents, sir. Positive sequence, negative sequence, and currents. This is
Okay.
only for currents. Above it is only for the powers. Directly three phase power and three phase current you will get.
Okay, ma'am.
Just you can enable PK, QK, and IK. So here the K and M represents the nodes. K represents the entering node. M represents the leaving node here for each and every component. So just you can enable the PK, QK, and IK and click OK. So here you can able to see the power flows through the switches. If you didn't get this one, just you can go to the design tab and you can refresh. Similar to the switches, we can take the transmission line power flows also similar to the switches. Just we can select the transmission line and go to the device steady state options. You can enable PK and QK for entering powers, and you can enable PM and QM for leaving the power from the transmission line. So if you select this like this, then you can able to find the transmission losses here. So in EMTP, we need to go for both entering power and leaving powers for calculating the transmission line losses. We need to do it through manual only. Like this, we can able to display the results on the GUI. Like this, we can perform the load flow analysis. And one more thing is, if you want to see these results, voltage results and current results in the complete system, we need to save these results in the Excel file. So for that, just you can double click on the view steady state, and here on the bottom side, you will find the save results into file tab. Just you can enable that save results into file, and you can enable save the results into Excel file. So to save the results into Excel file of voltages and currents, for that, just you can open the view steady state tab in your GUI, and you can enable save results into file and save results into Excel file. You can enable both one and click OK. After that, in the design tab, you will find the save voltage results into file and save current results into file. So separate files are available. So if you want to see the voltages, save the voltages in the Excel, then you can click on that save voltage results into file. So after click on the save results into file, here you can able to see the .csv file is available in the downside. Just you can click on that .csv file. This one, just you can click on this .csv file, and directly one Excel file is downloaded for you. So you can directly open this file in Excel. Just you can click on S, and you can find the whatever the bus voltages you have added. Here I am added both three phase voltages of the bus 1 and positive sequence voltage of bus 1. So you can get both all the voltages for bus 1 and bus 2. Directly you can save the results into the Excel file. So you will get the magnitude and phase angle directly in per units. Like this, we can go for the load flow analysis. So if you want to create a fault in this system, just you can go to the switches library. In switches library, you find the fault. Just you can drag and drop into GUI that fault. So I am creating a fault before the load here. Just you can connect like this. While double click on that fault, just you can double click on that fault. You can able to see the line to ground fault, line to double line to ground fault, or triple line to ground fault, triple line fault. All the faults you can able to do here by using the fault option from the switches library. So here just I am taking a 3-phase fault, and you can add the resistance as 0. Minimum resistance here I am taking, and you can close the fault in steady state and never clear. Just I am creating a fault in steady state and click on never clear and click OK. Like this we can create a fault. So this fault option is available in the switches library. Just you can go to the switches library and you can drag into GUI that one, and you can double click on that fault, and you can enter what type of fault you required. It's a line to ground or line to line fault, triple line to ground fault, anything you can enter. By default the fault resistance is here 1, so we have changed that resistance to 0. So in this example, just I am creating the fault in steady state and I didn't clear that fault. So you can click on that closed in steady state and never clear and click OK. So here I am creating the steady state fault. For that, just you can go to the simulate tab, simulation options, and you can disable this load flow solution and you can enable the steady state solution. Now we are creating a fault in steady state. For that, just you can go to the simulate tab, simulation options. You can disable find load flow solution and find time domain solution. You can disable both. And you can enable the find steady state solution and start steady state solution from load flow solution. So in EMTP, the load flow solution and steady state solutions are initialized automatically. So we are performing the load flow analysis. After that, we will go for the steady state fault. So for that steady state solution, just I am start the steady state solution from load flow solution and click OK. After creating the fault, just you can go to the simulate tab, simulation options, and you can enable the find steady state solution from load flow solution, and you can disable find load flow solution and time domain solution. Click OK. So to see the output results, what are the bus voltages at the time of fault? So here we need to add this voltage results as a steady state solution. Further, just you can double click on the view steady state tab and you can enable the results as steady state solution. Just you can go to the steady state tab and you can enable the results as a steady state solution and click OK. Now you can run the simulation. So to represent the steady state solution results into GUI, just you can go to the view steady state tab and you can enable the steady state solution results and click run the simulation. Now the steady state solution is completed and you can able to see the power flow results and voltage results at the buses. So because of the 3-phase fault, we are getting the voltage as 0.96 per unit on this bus. Like this, we can go for the fault analysis in EMTP. I hope all the people are completed this one. So just now we will go with the wind energy, wind turbine integration. For that, just you can able to see my desk GoToMeeting website, that you can able to see my share screen. For you, it is not possible to develop the wind energy because it has a more number of components in our wind park. Just you can able to see directly here. We can provide the recorded session with you. After that, you can develop your models and we can provide the trial versions. So for after that, just I'm connecting the wind park here. So just I'm removing this and I can exclude this fault. Further, just you can select that fault and right click. You can exclude this option. You can exclude this fault. Now I can connect the wind park at this bus. I can connect the wind park at this bus. So you can able to see the how we can do that one. So in EMTP we have a renewable energies library is available, renewables library. So just I'm going to that renewables library. So in that library you can find the type 3 and type 4 wind turbines, and similarly wind parks are also available. If you want to add the PV and PV parks, single phase PV panel, all these things you can find directly in the renewables library. So just I am taking the DFIZ wind park here. Just you can drag and drop the DFIZ wind park. Just I am rotating that one. So just I am taking the DFIZ wind park here. So to connect this DFIZ wind park, I can connect through switch. So just I can go to the switches library and take ideal switch with breaker symbol. Just I am taking ideal switch with breaker symbol here. And I can close this switch in steady state and never open and click OK. So I want to measure the power flow through this wind turbine. Further, just you can go to the meters library and you can take power P of T and Q of T 3-phase. So to measure the power flow through the wind park, just you can go to the meters library and you can take the power meter here and you can connect. So now I am connecting the wind park to this bus 2. So now I need to enter the parameters of wind park. For that, just here I am closing the switch initially and never open. So for this power meter, you can change the frequency to 50 Hz and click OK. Now you can click on this the DFIZ wind park. So here you can able to see the different tabs are available in the wind park, and similarly wind park PV park is also same here. The same tabs are also available in the PV park also. So here you can able to see the help documentation. So type 3 and type 4 wind turbines help documentation is provided here. You can able to see the complete documentation of control techniques and what are the control parameters, how it is connected, what is the harmonics tab. Each and every tab you can find here in the help documentation here. All the things you can find here. So some examples are also available. The detailed examples are also available. You can directly able to see in this documentation. So if you want to see the subcircuit of the wind park, further, just you can select that wind park and right click. There is a push into option is available. If you want to, if the in EMTP, if we have the any subcircuit inside the like exciters and governors, if you want to see the subcircuit of exciter and governors, wind parks, PV parks, so for that just you can select that wind park or component and you can right click. There is a push into option is available. So you can click on that push into option and you can able to see the complete subcircuit of that wind park. What are the controls we have used, how it is connected, all the things you can able to see in the wind park. So in this wind park here you can able to see the converter transformer and park transformer also we have added, and we have created this as a subcircuit, and we can convert the subcircuit as a masked parameters, and we can enter that masked parameters into the wind park. So if you want to see the here again there is so many subcircuits are available, just you can double click on each and every subcircuit, you will find the subcircuit detailed subcircuits are available here. If you want to change that subcircuits of anything, you can change, no problem for that. And you can create your own libraries also here. So in this example, to see the subcircuits, just you can select the component and right click. There is a push into option is available. Just you can click on that push into to see the subcircuit of component. So here we are creating it as a masked parameters for each and every subcircuit. So here you can able to see the different tabs. General tab. In the general tab, we need to enter the wind turbine parameters. So here I am taking my number of wind turbines as 20, and I can change the frequency to 50 Hz. And I can add my collector grid nominal voltage as 33 kilovolts, and my transmission grid voltage is 400 kilovolts. Here my equivalent system voltage is 400 kilovolts at bus 2. So I can add the transmission grid voltage as 400 kilovolts. If you have the zigzag transformer in the wind parks station, then you can include this zigzag transformer. Otherwise, you can disable that one. And if you can enter the single wind turbine parameters here. I didn't change anything here. So if you have the equivalent collector grid parameters, you can add equivalent resistance, inductance, and capacitance values. Otherwise, you can disable this one. So here you can able to see the operating conditions of wind turbines. Out of 20 wind turbines, just I can add 15 wind turbines are in service. Just out of 20 wind turbines, I can add only 15 wind turbines are in service. And there is a different control modes are available. Voltage control, power factor control, reactive power control. All the control modes are available here. So here just I am taking the reactive power control here. And next you can go to the park transformer tab. And here I am changing the nominal power of the transformer to 25 MVA. And nominal frequency to 50 Hz. And my inverter side voltage is 33 kilovolts. And my grid side voltage is 400 kilovolts. So I didn't change any RTX values here. If we have the magnetization characteristics, then we can include, otherwise we can exclude that one. Similar to the park transformer, just we can enter the inverter transformer values. Just I am adding my nominal power as 25 MVA. And I can change my nominal frequency to 50 Hz. And my grid side voltage is 33 kilovolts. So for each wind turbine, the voltage I didn't change here in the general tab. Here it is 0.575. I didn't change that one. So here also it is 0.575. And click OK. Like this we can enter the parameters of wind park. Just we can enter the general parameters, park transformer and inverter transformer parameters for normal, not detailed one. Just we are going for simple purpose. So if we are going for the control parameters, we have a different average value model and detailed model of control parameters are available. And we have a different protections are also available. If you want to enable that one, just you can enable that sag and chopper protection, LVRT and OVRT protections, all the things you can enter directly in this protections tab of wind park. Similarly, you have a park controller tab is available. If you have the VQ characteristics, then you can enter that one. Sometimes if we are going for the power quality issues, then we can model the complete wind park as a harmonic model. So for that, if we have the harmonic spectrum, then directly we can enter the harmonic values here. And we can enable this use harmonic model for steady state and time domain simulations. If we are going for some power quality issues at that time, if we have the harmonic spectrum of that wind park, just we can enter the harmonic spectrum here, and we can enable use harmonic model for steady state and time domain simulations. If we are enabled, automatically EMTP converts this wind park model into the harmonic model, and click OK. Like this, we can enter the parameters of this wind park. So after connecting the wind park, so again I will start with the load flow analysis. Here already it is slack bus is connected. So in this wind park, automatic initialization is available. So if you want to see, you can able to see that one in the sub-circuit. Here you can able to see that one. It is a PQ initialization or PV initializations are available based upon the control modes we are using in the wind park. So in the control mode, we are considering the reactive power control. So it is started with the PQ initialization. Automatically it will started. So no need to connect that one. Connect the load flow bus here. So after connecting the wind turbine, just you can go to the simulate tab, simulation options. I will start with the load flow solution and click OK. Now you can run the simulation. So in EMTP, in renewables library, wind parks and PV parks contain harmonic models, control modes, and park transformer and converter transformers with protection tab. So because of all these components, it will take time to simulate the completion of response. So it will take some time to respond the simulation. If you want to see the number of components, for that just you can select and right click properties. You can go to the properties and you can able to see the number of components here. So here the subcircuit size is 75K. That means more than 7,500 components are available here. So here for me, the load flow solution is ended here. Now we will go with the time domain simulation. For that, just you can go to the simulate tab and simulation options. Just I am disabling this find load flow solution and enable find time domain solution. So here I am increasing the main time step to 25 microseconds and my simulation time to 3 seconds. Yes, I can increase my main time step to 25 microseconds and my simulation time to 3 seconds. So here we are adding this main time step as based upon the frequencies. If we are going for the switching frequencies and lightning frequencies, then we can take it as in nanoseconds. Otherwise, we can take it as in microseconds. According to the requirement, we can change that main time step value. And here I can take in the maximum simulation time as 3 seconds and click OK and run the simulation. Now the simulation is started here. So before opening the simulation, just I will check the power flow through this wind park here before creating the fault. So before opening this power flow results in the M plot, I will tell the difference between the scope view and M plot for you. Why? Because for the demonstration mode, only we can provide the view scopes with M plot. For the trial version mode, we will get the view scopes with scope view. Just I am clicking both here, view scopes with scope view and view scopes with M plot. For the demonstration mode, EMTP demo mode, you have only the mplot results. Just I will tell the difference between the scope view and mplot here. So just I am clicking both here. So here the scope view is opened. This is the scope view. So in this scope view here you can able to see the signal type as control signal and node voltage. Wind turbine node, wind park node voltage you will get here. So here just I am go to the control signal. In the control signal you can able to see the PQM1/P at the rate of control. So in the meters library you can find the PQ meter name as PQM1. So in the scope view you will find that PQM1 as a name by active power or reactive power. This is the control signal represented as a control signal. So just you can click on that signals. While click on that signal you can able to find this in the downside. Automatically it will represented in the downside. So after that just you can click on that PQ reactive power control. So after selecting the signals just you can run the simulation. So like this you will get the response in the scope view. So if you are going for an mplot, just you can go to the control signal and you can find PQM1, P and Q. Just you can select the y-axis and you can select the reactive power and you can plot. You can click on S. So while clicking on, you will find the P and Q of your wind park here in the mplot. So in this mplot, you are not able to find the post-processing analysis of your waveforms, like if you are going for the current harmonics or voltage harmonics, or if you are going for FFT analysis, DFT analysis, you are not able to perform those values in this mplot. If you are going for the scope view, so in this scope view, you will get two windows, right? So one window is a signal window, another one is a graph window. So if you are going for the signal window, you find FX. This is the advanced function editor available in this scope view. Just you can click on that advanced function editor and you can select the categories of wherever, whatever you want. If you are going for the harmonic analysis, you can select the harmonic analysis and you can go whatever you required in this scope view. If you are going for DFT analysis, or if you want to get the harmonic numbers from 1 to 100, all the things you can able to get here. So just I can draw the node voltage also here. Just I can remove this one. I can draw the node voltage. So if you want to draw this node voltage in the second page, just you can increase that node voltage into second, increase that page number, and you can select one by one. You can select and run the simulation. So just you can select all the three waveforms and you can superimpose. Just you can select all the three waveforms and you can superimpose. This node voltage is wind park node voltage here. So here I want to find the voltage harmonics. For that, just you can go to the window tab. You can click on that advanced function editor. Here I am selecting the category as harmonic analysis. And I want to know the harmonics from first order to 100th order. So for that, you can select the function name as harmonic and you can provide the harmonic list as from 1 to 100. And you can change the fundamental frequency to 50 Hz. If you want, you can increase the page number to 3 and you can select each and every signal and you can click on that add function. Like this, we can generate the harmonics here. For 3 phases, I am adding here and run the simulation. Here you can able to see the harmonics here. Just I can zoom in y-axis. So like this you can able to see the harmonics directly in the scope view. So in mplot it is not possible. In scope view it is possible to perform the post-processing analysis, some mathematical analysis. If you want to add all the things you can able to do in scope view. So if you want to see the harmonic values, just you can select the waveform and right click on the show data. So if you want to see the 1 to 100 harmonic values, directly here. Like this, we can perform the harmonics in the scope view. So after that, just I am creating a fault here. Just you can click OK. And I am creating a line to ground fault. Single line to ground fault I have created. I can close my switch at 700 milliseconds. I can create a fault at 700 milliseconds. And I am clearing the fault at 900 milliseconds. Yes, I am creating a fault at 700 milliseconds. And I am clearing my fault at 700 milliseconds. Just I am creating a fault here and click OK. So, and you can run the simulation. So here I am creating a fault, line to ground fault I am created. 700 milliseconds I am created the fault and 900 milliseconds I am clearing the fault. So at the time of fault, you can able to see the response of your power flow from the wind turbine and what is the voltage response from the wind park. So just I am creating a fault and I am run the simulation here. So after running the simulation, just you can go to your scope view or plot and you can refresh your waveforms. Just you can go to your scope view or plot and you can refresh your waveforms. So here you can able to see the small disturbance occurred at the 400 milliseconds. So at 400 milliseconds, why this disturbance is happened means here we are using the converters, inverters, right? So because of the converter controls and other things, it will take some time to reach the steady state. So up to 400 milliseconds, this will work on the load flow analysis values, initialization values. After 400 milliseconds, it will convert it into the time domain simulation and it will give the results for time domain. So like this, we can get the results. Here we are closing the switch with 700 milliseconds. Okay. Just I can superimpose this one. Like this, we can find the simulation responses in the scope view and MPLOT, and you are able to understand the difference between the scope view and MPLOT in EMTP. But this MPLOT is also has advantages. Where we will get this MPLOT main purpose is if we are going for the switching transients and lightning transients, it is very important to closing time or opening time of the switch. So if we are going for closing time and opening time of the switch, if we are change 1 milliseconds, that 1 millisecond is also very important to get the worst values. So at that time, we will go for the statistical analysis to represent those statistical values. We require the template. So to perform the switching transients and statistical analysis, we will go for the MPLOT representation and we will get the worst peaks. So if we want to go for the FFT analysis or post-processing analysis, we will go for the scope view and we can directly able to see the results in scope view. Like this, we can able to see. And okay. So here you can, in the file tab, you can able to see the different applications here. For each and every application, you will find like renewables, synchronous machine and asynchronous machines, TRV analysis, line energization, lightning analysis, some IEEE examples, HVDC examples, power electronic examples. You will find a lot of examples are available in EMTP software. And similarly, if you want to understand the basic thing about EMTP software, so here you can go to the help and support tab, and here you can able to see some tutorials and reference values, and quick overview of EMTP is available. So here you can able to see the sub-circuit, how we can create a sub-circuit, how we can perform the, how we can change the names of buses, components, all the things you can able to see in the quick overview of EMTP. Like this we will go. Yeah, similarly for protection also we have a lot of examples are available. In the protection tab, you can find the different examples for differential protection, distance protection, loss of field, power swing protection, and one traveling wave detection example is also available in EMTP software. By using this traveling wave detection, here we can able to find the fault created at what particular distance. That example is already available in EMTP software. Yeah, if you have any doubts, you can ask now.
Participants, if you have any doubts, Monica ma'am is ready to answer your doubts. Please ask your queries.
So because of less time,
Madam,
yeah, ma'am.
ma'am, you told that it is possible to create restrike and pre-strike with the circuit breaker operation in EMTP.
Yeah, yes, ma'am.
Can you explain that with an example, ma'am?
Okay, ma'am. 1 second. Yeah. So here one example is available for TRV analysis, ma'am. Just I am opening
Okay,
one
ma'am.
example. Here there is a pre-strike example is also available. Just you can open the pre-strike.
Hello.
Yeah, hello, sir.
Hello. Can you
Hi.
hear me?
So similarly,
Hello.
if you find, ma'am, in the TRV analysis, we have a different IEEE models and the examples are also available. So because of the updated version of EMTP software, these examples are made before. So after that, we have a TRV breaker is available in EMTP software. You can find directly TRV breaker here. For that, just you can go to the switches library and you can find the breaker for TRV. So in this breaker for TRV, just you can drag and drop the TRV breaker into the system. And if you want, you can double click on the TRV breaker and you can find, ma'am. So here you can enable dot rating TRV and you can add the envelopes IEEE standard or IEC standard. If you want to define your own TRV envelopes, you can enable user define and you can change the shapes. 2 parameter or 4 parameter envelopes you can add. So here directly you can enable restrikes and pre-strikes.
Okay.
Yeah, directly you can take from this TRV breaker because this TRV breaker is available in the updated version 4.1 only. So directly you can enable the restrikes and pre-strikes directly. So here in this example, you can find the, so here they are added the user defined values. They are not added the restrike or pre-strikes here. So same example for the second table, they are adding the restrikes and pre-strikes. So to see the output responses, just you can run the simulation. Go to the simulate tab. Okay, I can delete this one. Just I can stop and I can rerun again. So like this, we can enable the restrikes and pre-strikes now. Directly we can, if you want to see the TRV responses and what is the protection margin of your breaker, for that also you can go to the some IEEE standard or IEC standard. Here you can able to see the two steps: find steady state solution and run the time domain simulation. If you are enable these two and click OK, then you will get the mplot responses for the TRV envelope and RRV envelope, and you can directly able to see the protective margin of that breaker directly in the GUI. Like this, you can able to get that one. So here the simulation is completed. So just I'm going with view scopes with scope view. And run it. transfer function editor I have removed. Here you can able to see different control signals, ma'am. Breaker 1, TRV, delay control, all the things you can able to see what is the breaker gap, all the things you can find.
Okay.
Similarly, switch current also you will get. Like this you can find, ma'am. Like this we can add the pre-strikes and restrikes in the TRV breaker directly.
Thank you, ma'am.
Yeah. Anyone has it out? You can ask now. So after ending the session, I will share the recorded session and PPTs with you. Ma'am, I didn't able to hear your voice. Hello?
Now, can we incorporate artificial intelligence techniques to our system?
No, ma'am, I didn't get you, ma'am. Hello?
Okay, I'll type in chat box.
Hello?
Madam, can we implement artificial intelligence techniques into the system, ma'am? That's what the madam's query is.
Okay, for that artificial intelligence techniques related to the MATLAB, it is not possible. So fuzzy logic and all the things are not available. We can write our programming in the JavaScript. So in EMTP, it is available. If we are going for the programming, just we can go with the JavaScript and we can write our programming according to that one.
Elements we can add to this using EMTP.
Or otherwise, you can create your models in the MATLAB, ma'am, and you can import those models into the EMTP software by using DLL. So in EMTP, DLL is available. Simulink DLL is available. Just you can take the DLL and you can interface from MATLAB or Simulink to this EMTP software, and you can connect this DLL and you can work. So here you can able to see the documentation, how you can import that MATLAB programming or coding or Simulink model into the EMTP software directly. You can find the detailed documentation, ma'am. Step by step you can follow and you can import into that model or that programming into GUI and you can connect accordingly to your system and you can run. That is an advantage here. Hello, ma'am. Is it okay?
Yes, ma'am. Ma'am, another question. How many number of elements I can add into the system? Is there any limitation?
Any limitation means it's number of devices or anything, ma'am?
Yes, ma'am.
Okay, for trial version it is 5,000 devices, ma'am. For licensed version, it is increased to 10,000. It based upon the college requirement, we can provide the number of devices for the licensed version. But for the trial version, it is hello.
How can I use the trial version once it is installed?
Ma'am, sorry, ma'am, I didn't get you. Your voice is very low.
Once it is installed, how long can I use the trial version?
15 days, ma'am. If I am created the trial version today, then it will start from today itself. So after 15 days, it will expire. with all modules, we can provide the 15 days trial version.
Madam,
Yeah, hello, ma'am.
for this version, can you increase the number of devices?
For the trial version, it is not possible, ma'am. For the trial version,
Okay.
5,000 devices, it is possible. We can able to do the renewable energy integrations, all the things we can able to do it.
Okay.
And we can add different modules also related to synchronous machines like exciters and governors library, Simulink box. We can provide all these modules with you for 15 days trial version. If you are requested for the trial version, then we can provide, ma'am. Just you can go to the EMTP website and you can request.
Yes.
You can provide your
Yes, ma'am.
details, ma'am. So accordingly, we can provide the trial version with you.
I did the same, madam. I have logged into EMTP website and I put a request to get the 15 days trial version.
Okay, when you are logging, ma'am.
Today only, madam.
Okay, ma'am. We will provide.
Okay, thank you, ma'am.
Okay, ma'am. Thank you, ma'am. You are the student or professor, ma'am?
I am faculty member in Vienna Vignan Jyoti, madam.
Okay, ma'am. Okay, ma'am. We can provide, ma'am. For
Actually,
professors, we are providing.
madam, actually we purchased licensed software from you. But
Okay.
because of lockdown, we could not go to college. That's why I'm asking you for 15 days trial version.
Okay, ma'am. Yeah, that I will discuss with our management. I will provide, ma'am. No problem. For 15 days trial version, it is possible.
Okay.
Okay, ma'am. I will provide.
Oh, thank you. Thank you, ma'am.
Okay, ma'am. Thank you.
Madam, can we have your mail ID for
Yeah, sure, sir. I will.
the queries?
Yeah, sure, sir. I will share. Yeah, these are the contact informations for sales and technical support. If you require my mail ID, I will provide my mail ID also here with Bhupati, sir.
Is it iPhone, madam? Aunque iPhone MK, madam?
No, sir. This is the only mail ID. The underline
Okay,
section
MK
is the
dot.
only. Yeah, mk.monica@pwsim.com.
Okay, ma'am.
Okay, sir. You can contact any one of the person. And similar to the FDP programs and workshops, we can provide the paid training programs for advanced training also. So in the month of July, we have providing the 4 days advanced training program on switching transients, lightning transients, ferro resonance analysis, transformer modeling. 4 days we have provided. It is a paid training program. If anyone are interested, you can register for that. Just I will open the agenda of the training program. EMTP. Because it is advanced training program, the cost is also very high. For students, it is 5,000 plus GST, and for faculty members, it is 10,000 plus GST. So in this 4 days, we will go with a lot of examples for switching transients, resonance and ferro resonance examples with single circuit and double circuit transmission lines, statistical switching analysis, and PIR switching. All the things we will discuss at the time advanced training program. So along with the PPTs, I will provide this agenda of the training program also with you. Just you can share this to your students. If possible, if they are interested, they will join. Hello. Hello? Hello, sir. Hello?
Okay, ma'am. Shall we conclude the session or any doubts for the participants?
Yeah.